Good afternoon to all of you. I am Aarchi from Standard 9 and now I am going to deliver my speech on the topic of geometry, geometrical shapes. Further, I will increase my speech to some formulas, how to measure the area, how to measure the perimeter, how to measure the volume of some 2D and 3D shapes. So, first of all, I would like to discuss about geometry. Firstly, geometry was discussed by Euclid. Euclid gave his geometry in the book Element, in which he classified the book Element into 13 chapters, in which he described every figure in a short way. He also gave his seven axioms and his five postulates. His seven axioms are things which are equal to the same thing are equal to one another. The second one postulate is the things which is added to the if equals are added to equals, then the wholes are equals. The third one is if equals are subtracted from equals, then the remainders are equal. And fourth one is things which coincide on one another is equal to one another. The fifth one is the wholes are greater than the part. The sixth one is things which are double of the same thing are equal to one another. And the seventh one and the last is things which are half of the same things are equal to one another. Euclid also gave his five postulates, which were a terminated line can be extended infinitely. From two distinct points, a special, a unique, a straight line can be formed. All the circles, all the right angle triangles are equal to one another, and all the circles can be created by a center and a radius. The last one is also known as Playfair's axiom, which says that when a transversal falls on two non-parallel lines, then the side on which the co-interior angle sums less than 180 degree, those sides, when extended infinitely, will intersect at a point, will meet at a point. Next, I would like to discuss some terms which Euclid defined. The first one is point. A point is an exact location. Length. Length is something. The length is the unit of measurement. Breadth is also same and height is also the same. Next one is a line. A line is created from various points lying in a straight line. If we will join millions of points or various points, then we will get a line. The next I would like to say about line segment. When we end a line from 2 points, in between of them a line exists, then it is a line segment. Or we can say it as when 2 points are when a point is extended to the next point, then a line segment is formed. The ray. Now I would like to say about ray. A ray is a type of line in which its one side is it have one point and another side can be extended infinitely. To represent the line or line segment or ray, we just put the letters of the point and we apply the line. If it is a line, then we draw a line and we should draw 2 arrows on both sides of that line. If we have to draw a line segment, then we have to write the point in between which the line segment is lying, and we don't have to put the arrows which we put on the line. We just have to create 2 points. And to denote a ray, we have to draw a line, a small line. We have to write the points of names below it, and then we have to create an arrow at the next side on the opposite side of the point. Next, I would like to say about the lines and angles. Lines I have already discussed, and now angles. When two rays originate from a single point, then the figure obtained is known as an angle. An angle is also of various types. First one is acute angle. Second one is obtuse angle. Third one is right angle triangle, and the fourth one is reflex angle. The angle, I would like to draw an attention that we measure an angle through a protractor. Now continue to angles. The angle which have its measure less than 90 degree, then this angle is known as acute angle triangle. The angle whose measure is correct 90 degree is known as a right angle triangle. The triangle whose measure is more than 90 degree is known as obtuse angle triangle. The triangle whose angle is more than 180 degree and less than 360 degrees is known as a reflex angle. A complete angle is an angle when one arm is still and the second one arm is moving and reached at the fixed and when it fixed and it reaches near the fixed line, then it is known as a complete angle, which is 360 degree. A straight angle is an angle of 180 degree, and a zero angle is an angle of 0 degree in which both lines are present at the same point. The next, I would like to say about the now I would like to say the theorems which are present in the chapter lines and angles. I would just tell the statements of those theorem. The first theorem is when two adjacent when a ray fall on a straight line, then the sum of both the adjacent angles are 180 degree. By this theorem, there are two corollaries, which are if a ray falls on a line and the one ray is just opposite and the two rays are just opposite to one another, then the angle of that figure is 180 degree. And the next one corollary is a point has an angle of 360 degrees. Next, I would like to discuss about theorem number 2, the statement of theorem number 2, which is when two lines intersect each other at a common point, then the vertically opposite angles formed are equal. The next, I will discuss the theorem 3rd, which here a new concept arises of a parallel line. A parallel line is something when two lines originate from two distinct points and it is continued till infinity and the distance between those points is same, then it is known as the parallel lines. Here one more concept arises of a transversal. When these two lines are cutted through a slant line, then the slant line is known as the transversal. Now, I would like to say the fourth theorem, which is if a transversal cuts two parallel lines, then the alternate opposite angle formed, the alternate interior angle formed is equal, and just opposite to that, some alternate opposite exterior angle are also equal. Now, I would like to say about the 5th theorem, which is that before that I would like to say a statement which is truth, which is accepted as a truth, that is the corresponding angle formed on two parallel lines which is cutted by a transversal is equal. This statement not requires a proof. This means that this is an axiom. Next, I would like to say about the theorem number 6, that is the converse of the theorem number 4. Here it says that when a pair of alternate opposite angle is equal, then the two lines between which the exterior alternate opposite angle is formed, they both are parallel. Next, I would like to say that the bisector of both two alternate opposite angles are parallel. Next, I would like to tell about a new figure, which is triangle. A triangle is a figure formed by three line segments. These three line segments are jointed on three vertices, or we can say on 3 points. Here, a triangle have mainly 6 parts, which are its 3 sides and its 3 angles. A triangle is also of various types. the first type of a triangle on the basis of their triangle is classified on two bases. First on the basis of their angle, and second one is on the basis of their sides. On the basis of their sides, triangles are of three types, which are scalene triangle, isosceles triangle, and equilateral triangle. And on the basis of angles, triangle is of three types, which are acute angle triangle, obtuse angle triangle, and right angle triangle. Here, in obtuse angle triangle and in right angle triangle, one angle is obtuse, or one angle can be right angle, and the left two angles are acute angle. So we can conclude here that if any one angle of a triangle is 90 degree or more than 90 degree, then the two angles another formed are acute. So we have to notice that if there is a right angle or obtuse angle, it must be that triangle only, not the acute triangle, according to those two sides. Now next, I would like to discuss about some parts of the triangle. The first is median. Median is a three line segments where these line segments originates from the three vertices, meet at the same point, and next it lies on any side of a triangle, cutting it from its middle point. These three medians lie on a same point. The second one is in center. If a circle is drawn inside the triangle, then if the circle touches its all the three sides, then it is known as the in center. Another concept lies here, that the radius of that in center is known in circle is known as in radius. Also, now I would like to say about the. Now I would like to discuss some 2D figures like quadrilaterals. Here, the sum of all angles of a quadrilateral are 360 degrees, which are twice of a triangle. If we look at a rectangle or any quadrilateral, we can observe that there are two triangles formed. By joining those two triangles, a quadrilateral is formed. Now, I would like to say, now I have discussed about the triangles. I would like to say the formulas to calculate the area, the perimeter of the triangles. First, the area of the equilateral triangle is root under 3/4 into side square. Now, the next one, that is, if we have to calculate the area of a scalene triangle or an isosceles triangle, we will use the Heron's formula. This formula was discovered by Heron, and who is a scientist, and he said that his formula was root under s into s minus a into s minus b into s minus c. Here the s is the semi-perimeter, which is calculated by adding all those sides and dividing it by 2. So this is a universal truth. This formula also do not requires any proof. The formula of scalene triangle, the formula to find the area of isosceles and equilateral triangle can be derived from the Heron's formula. The next, I would like to discuss about quadrilateral. Quadrilateral is a figure which is formed by 4 line segments, or we can say the area enclosed by 4 line segments are known as a quadrilateral. Here, for a simple quadrilateral, the formula to find its area is 1/2 into height 1 plus height 2 into its diagonal. This is the universal formula for any quadrilateral to find its area. But when we have to find the area of a trapezium, then the formula is 1/2 into sum of the sum of 2 parallel sides into height. So this formula varies in different types of quadrilaterals. Here the quadrilaterals have various types. First, which is a square. A square is a figure formed by 4 line segments, and these all 4 line segments are equal to one another. Next, that is rectangle. In rectangle, the opposite side of rectangle are equal, and in both square and rectangle, its vertices make an angle of 90 degree. Here, A square, here a note point comes that a square can be a rectangle, but a rectangle cannot be a square. Now next I will move to rhombus. Rhombus is a figure similar to square but not totally similar. In rhombus also, all the four sides are equal, but the vertices of the rhombus do not bear an angle of 90 degrees. It can be less than 90 degrees or it can be more than 90 degrees. Next, I would like to discuss about the parallelogram. The parallelogram is a quadrilateral which is formed by four line segments in which the opposite line segments are parallel. Here, in parallelogram also, the vertices do not bear an angle of 90 degree. Here also, a note point comes that a rhombus can be a parallelogram, but a parallelogram cannot be a rhombus. Now, I would like to say about the kite. Kite is also a type of quadrilateral. Here, a kite is also a type of quadrilateral. Here two adjacent sides are equal. Here two adjacent sides are equal. Now next, I would like to say about trapezium. In trapezium, two sides of a trapezium are parallel, and there are two non-parallel sides. The formula to find the area of a square is side square. The formula to find the area of a rectangle is length into breadth. Now next, the formula to find the perimeter of area of a trapezium is 1/2 into sum of two sides into height. Here in this trapezium, its one vertices can bear an angle of 90 degree, but all vertices cannot bear an angle of 90 degrees. Next, I would like to discuss about some 3D shapes. These were all about 2D shapes. Now I would like to discuss about some 3D shapes, which are like cube, cuboid, cylinder, next a cone, hemisphere, sphere, pyramid, and etc. First of all, I would like to discuss about cube. Cube has 6 faces. Cube has 6 faces, 12 edges, and 8 vertices. Here, the formula to find the total surface area of a cube is 6 into side square, and we can calculate the lateral surface area of a cube, which means that we would not count any of two surfaces of a cube. We generally use the top and the bottom of the cube to calculate the lateral surface area. By leaving them, we just have the four. We are just left with the 4 sides, which we have the formula to find, which is 4 into side square. The formula to find the volume of a cube is side cube. There is some formula to calculate the diagonal of a cube, which is root under 3 into side. Now I will move further to cuboid. Cuboid has 6 rectangular faces. Here in cuboid, there are 12 edges and 8 vertices. It seems like cube. Here also a note point comes, which is a cube can be a cuboid, but a cuboid cannot be a cube. Next, I would like to say about the formula to find the total surface area, then lateral surface area and volume of cuboid. So the total surface area of a cuboid is 2 into LB plus BH plus HL. The lateral surface area of a cuboid is 2 into H into L plus B. Next, the diagonal of a cuboid is root under L square plus B square plus H square. Then the formula to find the volume of a cuboid is length into breadth into height. So this was all about cuboid. Now next, I am moving further toward the cylinder. A cylinder is a figure formed by 2 circles and 1 rectangle. When a rectangle is folded, then it forms a cylinder. Now I would like to say about the formula to find the total surface area, the lateral surface area, and the volume of a cylinder. In cylinder, a new concept arises, which is the concept of hollow cylinder. So first I would like to discuss about the cylinder, and then I will move further to the hollow cylinder. The total surface area of a cylinder is 2 pi rh plus 2 pi r square. The curved surface area of a cylinder is 2 pi rh, and the formula to find the volume of a cylinder is pi r square h. Next, I would like to move on the hollow cylinder. First, I would like to discuss that in a hollow cylinder, a cylinder lies, and inside of it, one more cylinder lies, and both the cylinders are connected, and the space which is present in the middle is hollow. That's why its name calls as hollow cylinder. Next, I would like to say the curved surface area of a hollow cylinder, which is 2 pi capital RH plus 2 pi small rh. So next, I would like to discuss about the volume of hollow cylinder, which is pi capital R square h minus pi small r square h. This is all about geometry and its shapes. And thank you to all.